Hey everyone, hi, hello, good evening. So good to see you again. Virtually, of course. I can see Narendra Kumar is there, Anchita is there, Ritvik is there, Suhani is there. Hi Mukesh. Hey Papya. Hi Prakhar. Hey Nibha. Hi Ayush. Hello Prakhar. Tree plant says hello, hello tree plant. Hey Onati, how are you? I hope you're safe and I hope you're doing really great. Hey Dharya. Hi Amisha. Hi, hello. Good evening, Ankita. Hey, Ashish. Hello, Divya. I am doing well, thank you. So, this is like your set pattern. First, it's going to be hi or hello, good evening, ma'am. And then you ask me, how are you, ma'am? And then you ask me, is there a Menti quiz today? So many of you are asking the same question over there. Yes, boss, there is going to be a Menti quiz today. But before we start with all this, you need to first confirm if I'm perfectly audible or visible. Yes? So you need to check the clarity of the PPT. Is the audio working fine? Is the video working fine? Hi Paramveer. Hey Andy. Hi Akshay. Akshay says no audio. Okay. Is this happening with everyone? Anshita says perfectly audible and visible. Ashish is also saying that. Akshay, you need to check your connection once again then. All right. Hi Pranavi. Hi Maulik. Okay, if I'm perfectly audible and visible, then you do one thing. You know what elements are, right? And you know the symbols of these elements. So, post the symbol of your favorite element. So, if I see a lot of symbols coming up, I would know that entire setup is working fine. And there is no technical glitch. Let's see कि आपका favorite element कौन सा है. Yes, absolutely. धीरे धीरे बहुत वेल वर्स हो जाएंगे हम केमिस्ट्री के साथ भी. So many of you writing oxygen. Well, that is actually really important, right? I can see silver also. Sodium, neon, great. Gold, nice. So you are basically confirming that you know the symbol as well as you're confirming that this setup is working fine. Awesome. Hey Akshay, H2O is not an element. And he says silicon. Ishika says carbon. Uranium. Great. Zinc. Magnesium. Ashish, that's a funny one. Alright. Papya is stating the last element that is being discovered. Alright, nice. Let's just wait for some time so that everybody is here and then we can have a great session together. Meanwhile, what I can do is I can share some interesting facts with you. So you know about Thomson, right? And you know about Rutherford. Today you will know about Bohr and we'll also study about Chadwick. Now Chadwick was actually a student of Rutherford and Rutherford was a student of Thomson. Just imagine this classroom. Isn't it? I'm sure it was really fascinating, right? A classroom full of discoverers and scientists. Well, we can't even imagine what their discussions would have been like. Yeah? Yes, absolutely. क्या पता आप में से कोई एक साइंटिस्ट बन जाए? Nice. Yes, there is going to be a Menti quiz, which means you need to be really attentive throughout the session, right? Then only you're gonna score really well over there. Thank you, Vaishnavi. Yes, it's a weirdly interesting fact actually. Great. All right, I think everything is working fine. We are settled and we are good to go. So, before we start with Bohr's model, let's see what we've already covered till now. We already know about Thomson, right? And in the last class, we were studying about Rutherford. Let's recall the postulates of Rutherford based on alpha rays scattering experiment. Now, the first postulate that he had given was that there is a nucleus. There's a positively charged center, that is the nucleus, and it's present in all the atoms, right? Electrons revolve around the nucleus in circular path. And the size of this nucleus is really small as compared to size of the atom. Alright, I can see that time lag is happening over here. Alright. Many kids are saying it's lagging. Just refresh it once and I'm sure it's going to be fine. Just refresh, join back again. Alright, no lag now. Great. Now, Rutherford gave these postulates, but there was a major drawback. And what was the drawback? Well, let's recall that. He said electrons are revolving in circular path. Electrons are very much charged particles, right? If they are revolving in circular path, they are accelerating, and in a way they are liberating energy. They are releasing energy. They are losing energy. If they are losing energy, eventually they are going to fall into the nucleus. As you can see over here, like this. If this happens, an atom is not going to be stable, right? But we all know an atom is very much stable. So, Rutherford could not explain the stability of an atom. That's why we need more models, right? Alright, so let's go back in this year 1913 and let's see who gave the next model. So Niels Bohr came up with his model that is known as Bohr's model. Yes, can you guess he's from which continent? Let's see how many of you can figure that out quickly. Some of you are saying the video is still lagging. Some of you are saying no, it's working fine. Guys, just refresh it once. Just refresh. Alright, now based on your comments, you're giving me a thumbs up, you're giving me answers of the continent, then I'm sure it's not lagging anymore. Europe, and you are absolutely right. Now, he came up with this model and he did some tremendous work, right? For which he was given Nobel Prize, and it was in the year 1922 for his work on structure of atom. फिर तो ये पढ़ना बिल्कुल बनता है. Let's see what did he say. First of all, he said that these electrons are revolving. They are basically moving in special discrete orbits. And suppose you've got the nucleus over here. This is the nucleus. This is your first, okay, I'm gonna let this go. This was not really circular. This is your first orbit. This is your second orbit. Or you can call it shell also. Right. So there you go. There are discrete shells and only special orbits, which are known as these discrete orbits of electrons, are allowed. Mukesh says energy shells. Nice. Akshay is telling the names of these shells. Okay. Great. Now, he also said as long as the electron is revolving in a particular orbit, it's not going to radiate energy. So while revolving in discrete orbits, electrons do not radiate or release energy. So this makes an atom very much stable because it's not losing energy anymore. It's not going to fall into the nucleus, right? So in a way, the drawback of Rutherford is being covered over here. Yes? Alright, great. Absolutely, KLMN. Nice. Okay. As you people have already mentioned over here in the chat box, these orbits or shells are being represented as K, L, M and so on. Now, clearly the innermost shell is your K shell and small letter n that you see over here is your shell number. So for K shell, n is equal to 1. Then the next shell is your L shell. For L shell, n is equal to 2. For M shell, n is equal to 3. For N shell, n is equal to 4. So, we've just made 4 shells over here. Alright. Why is it not ABC? Interesting question. Why is it not ABC? Why is it KLMN? Anyone? Okay, because my name starts with K, that's why. Okay, just kidding. This is obviously not the answer. Read about Charles Barkla. So Charles Barkla came up with some experiment based on X-rays. That is why this naming of these shells starts from KLMN and not ABCD. So you're going to read about Charles Barkla for this. How many of you are inquisitive enough to go back and read about this? Quick thumbs up in the comment section and I'll understand. Great. Nice. Awesome. Chalo. Now, how are these electrons basically distributed in different shells or in different orbits? There must be some order. Randomly to nahi placed honge. That is what we are going to cover now. Let's see. So, Bohr and Bury, they came up with a scheme that is known as Bohr-Bury scheme, which gives this main idea about how many electrons can be present in a given shell. So, maximum number of electrons that are allowed in a given shell is given by 2n square, where you know n is your shell number. Alright, first you've got the nucleus. Okay, then let's see which is the innermost shell. Innermost shell is your K shell with shell number equal to 1. All you have to do is put n equal to 1 in this formula and you will be able to calculate the number of electrons in that particular shell. So 2 into 1 square gives you 2. So we've placed 2 electrons over here. Aditya says, ma'am, can you please repeat the drawback of Rutherford's model? Yes, I'm going to do it within a minute. Just give me a minute. Let me just cover this and then I'll come back and tell you the drawback of Rutherford's model. Now, when shell is your L shell, that is n is equal to 2. Now you're going to put the value of n equal to 2. Basic maths. So it's going to be 2 into 2 square, which is 2 into 4, that is 8. So we've placed 8 electrons in the L shell. Moving on to the next one, that is M. For M, n is equal to 3. So it's going to be 2 into 3 square, which is 2 into 9, that is 18 electrons. So we've placed 18 electrons over here. Alright, let's see what is the next shell. We've got the next shell as the N shell. For N shell, n is equal to 4. So it's going to be 2 into 4 square, that is 2 into 16, which is 32. Now you people are going to find out for O shell. So for O shell, find out what's going to be the number of electrons that can be placed over there. Meanwhile, I can quickly recall Rutherford's drawback. So, electrons are revolving in circular paths, right? And if they're revolving, they need some acceleration. While they're accelerating, what is happening? They are going to release some energy. They are losing some energy. And if they're losing energy slowly, eventually they're going to fall into the nucleus of that particular atom. If electrons are falling and collapsing into the nucleus, an atom won't be stable, right? But we all know that an atom is stable. So basically, Rutherford could not explain the stability of an atom. Alright, I can see Aditi is saying 50, Dhera is saying 50, Ankita is also saying 50. Alright, yes, absolutely. So, for O shell, n is equal to 5, right? Now, if I write for O shell, n is equal to 5, this is going to be 2 into 5 square. Now, 2 into 5 square, 2 into 25, there you go, 50. Nice. All of you got the answer correct. Shika is also saying 5. Great. Aditi, I'm going to come back to your doubt. We are going to cover that part as well. Absolutely, 50 electrons in the O shell. Great. Chalo, let's move on. Now, there are basic rules that you need to remember while writing the configuration. Maximum number of electrons that can be accommodated in the outermost orbit is 8. So, maximum number of electrons that you can place in any of the orbits, if it's the outermost orbit, it's going to be 8. But if the outermost orbit is k, then the maximum number of electron is going to be 2. So except k, if you have L, M, N, and so on and so forth, if that's the case, it's going to be 8 electrons, like you can see over here. But if it is K shell, in that case, you can put 2 electrons in the outermost shell. Great. Yes. These are the rules that you need to remember. RTG legend, we are going to come back to this. Yes, Ayush, absolutely right. For K, it's going to be 2. For rest of them, it's going to be 8. Done? Understood? All right. Let's move on and let's see. We've placed 2 electrons in K shell if it's the outermost one. If the outermost shell is L, M, N or any other shell, it's going to be 8 electrons. Now, another very important rule. Electrons are not accommodated in a given shell unless the inner shells are completely filled, which means that you need to fill the inner shells first. Let's see over here. Look at this example. You've got K shell, you've got L shell, right? You've placed the first electron in the K shell. Now, without putting the second electron in the K shell, without completing the K shell, rest of the electrons are being put in the L shell. So this one is absolutely a big no. That is not the right way to distribute the electrons. What is going to be the right way? Well, let's see. Over here, again, we've got KLN shell. In the K shell, you can put 2 electrons. We know that K shell can accommodate 2 electrons, right? And the rest you can put in L shell. Yes. So, this is how you need to distribute the electrons. Now, we know about electrons, we know about protons. So, she is saying that mass of an atom is mass of protons plus mass of electrons. I'm not saying that. She is saying that. Do you agree with her? Let's see how many of you agree with her. Yes, we will start with that also, don't worry. No, incorrect, okay. So you don't agree with her. According to her, mass of an atom is mass of protons plus mass of electrons. Absolutely. You people are absolutely right and she is not right. She is incorrect. She is absolutely wrong. Actually, when it was found out the mass of an atom, it was way more than this, what she is saying. So, there is another subatomic particle which is contributing to the mass of an atom. This subatomic particle is neutron and Chadwick discovered this neutron. Now, neutron, as the name suggests, is neutral. That means it has no charge. This neutron is having no charge. Okay. Moreover, how do you represent this? You represent this using small letter n. Now, there are few characteristics of neutrons. For example, you know about the charge of neutron. You should also know about the mass of neutron. Mass of neutron is nearly equal to that of a proton. Now, I have a trick question for you. Can you think of any atom in which no neutron is present? Think about it. You've got to use your head to answer this one. Is there any atom in which no neutron is present? Let's see who's going to answer this one. Hey, absolutely right. So many of you have answered this one correct. Shikha, Pari, Vidushmita. And the best part is the reply was really quick. The answer is hydrogen. So neutrons are present in the nucleus of all atoms except hydrogen. Great, Lakshmi. Absolutely right. Ashish, Dinesh, Anshita, Sahil. Awesome, guys. So, we are going to come to the structure of hydrogen because that's an important topic. So, I'll put a star over here. We are definitely going to come back to this one. Great. Now, this is how your atom looks like. In the center, the yellow spheres that you see, they are the neutrons. They are very much neutral. The positive red spheres that you see, they are the protons, and electrons are revolving around the nucleus. Now over here, mass of an atom is going to be very basic, mass of proton plus neutron plus electron. But hey, mass of an electron is negligible as we compare it with mass of proton or mass of neutron. In fact, 9.1 into 10 to the power minus 31 kg. That's actually the mass of an electron. Such a small number that you can neglect it as compared, if you're going to compare it with mass of proton and neutron. So this gives you mass of an atom which is equal to mass of protons plus mass of neutrons. Absolutely right, Diksha. Parvati, we're going to come back to this really soon. 2000 times. True. Nitya is asking, do you have BYJU'S classes every day? Yes, we have BYJU'S classes every day. Every day we are covering some subject or the other. So you need to subscribe to the channel. That's how you will be getting all the notifications. All right. So let's quickly recall whatever we've done so that when we are going to have Menti quiz, you people can answer everything. Starting with Bohr's model. So only special orbits which are known as discrete orbits are being allowed, and only electrons are revolving in these orbits. While revolving in a particular discrete orbit, these electrons do not lose energy, and that is why we can actually state the stability of an atom. Now these energy levels that we have are being represented as K, L, M, N and so on, right? For which N is equal to 1, 2, 3, 4 respectively. Then we also studied about Bohr-Bury scheme. Maximum number of electrons in a given shell is given by this formula 2n square. So all you need to do is substitute the value of n and you will be able to calculate the number of electrons. But here remember, maximum number of electrons that can be accommodated in the outermost orbit is 8, except if it's the K shell. For K shell it's going to be 2. Now electrons cannot be accommodated in a given shell unless the inner shells are filled. So inner shell needs to be filled first. For example, if say suppose if I need to fill 11 electrons, right? Correct will be 281. So if you make it 182, over here K shell has 1 electron, so this is wrong. If you make it like 272, then also this is wrong because L shell is not filled. Only this is the correct one. Okay, so remember this, that inner shells need to be filled first. All right, then we studied about neutrons, which was being discovered by Chadwick. It is represented by small letter n. It has no charge and the mass of a neutron is very much equal to mass of a proton, while the mass of electrons are negligible as compared to masses of protons and neutrons. Neutrons are present in the nucleus of all atoms. There is an exception. We're going to come to that exception in the next class. All right, now it's the fun time. I know you people are waiting for this. It's the quiz time now. What do you have to do? You know the drill, right? You need to go to www.menti.com. Over there, they're going to ask you for a code. The code is 4342875. This is the code that you have to enter. 4342875. So go to menti.com and enter this code. Quickly. We've recalled all the important concepts as well, right? All right, I can see a football, I can see a crocodile, watermelon, fox is there, diamond ring is there, rabbit is there, cat is there, hat. Slowly people are joining. Guys, come on. Ask your friends also to join. This is the most amazing part of this session, right? Menti quiz 4342875. Quickly. Nice. I can see many of you joining now. Great. You can ask your friends also. This is like a game that we're going to play, right? Amazing. Vidushmita is saying dinosaur is mine. If you're facing any issue while joining, you can let me know. Let me know in the comment section so that, it can be fixed. And you can also be a part of this quiz then. All right. Dragon. Okay, let me find that out. Yes. I can see. Yes, I can see a strawberry. Difference between atomic number and atomic mass. We're going to come back. We're going to come to that in the next class. Don't worry. We will be covering everything. Diamond ring. Okay, give me a quick thumbs up if everybody is here, so that I know that we can start with this quiz. Quick thumbs up in the comment section. All right, Ritvik, noted. I hope you people have been really attentive during the session, because whatever questions will be asked right now are completely based on the concepts that we've covered today. Yes, easy peasy, great. All right, I can see loads of thumbs up. I can see most of you have joined. Chalo, let's begin then. I hope you all are ready. Yes? Chalo, all the best, and let's see what's the first question. Guys, you have to be quick, you have to be precise, no silly mistakes, okay? Let's see what's the first question. The question is, which scientist gave the concept of fixed energy levels around the nucleus? Option A is Rutherford, option B is Thomson, option C is Niels Bohr, and option D is Goldstein. You know about all these scientists, right? And you know who did what, right? Let's see who is going to answer this one correctly and instantly. I can see a lot of you are posting answers in the comment section. Okay. 60 of you got this one right. Well done. Great. Awesome. Most of you could understand what is happening over here, which is a nice thing. That means you people were attentive during the session. You people are right. Option C, Niels Bohr gave the concept of fixed energy level around the nucleus. And K, L, M, N, these are the shells, for which N is equal to 1, 2, 3, 4 respectively. It's okay if you got one wrong. That's not a problem. There are many more questions left. 6 more questions left. Anshita wants to see the leaderboard. Not right away. Let's solve some questions, and then I'm going to show you the leaderboard. All right, moving on to the next question. Let's see what is question number 2. All right. Question number 2 is right in front of you. What is the general formula to represent the number of electrons in a given shell? And they've given you 4 options, जो बहुत close है एक दूसरे के, isn't it? Option A is 2n, option B is 2n square, option C is n square, and option D is 2n minus 2. Let's see who's... I think all of you should get this one right. We've actually discussed this in great detail today. I hope you've got this one right, and let's see. 70 of you got this one right. Awesome, guys. Well done. Yes, I'm really happy. Great. Nice. All right. For the ones who did not get this one right, that's okay. That's not a problem. Maximum number of electrons which can be given in a shell, which can be put in a shell, is given by the formula 2n square. That's how we calculated how many electrons to put in K shell, L shell, M shell, N shell, and so on. Yes, don't be sad. Absolutely. Diksha, you're right. Now Pabia wants to see the leaderboard. I'm going to come back. I'm going to come to the leaderboard, but after this question. Okay, after question number 3, I'm going to show you the leaderboard. First, you need to solve this question. This question says, let's see, the maximum number of electrons that can be accommodated in the M shell is. You people have to calculate for M shell, KLM. For the ones who've just joined us, let me repeat the code for you people. The code is 4342875. This is the code. This is the Menti code. You can quickly join from here also. Just go back to basics to answer this one. It's a very simple question, right? And you know the formula also now. Now this is basic maths. Most of you got this one right. I'm sure the rest of you must have done some silly mistake because all you had to do was just substitute the value. You just had to put n equal to 3. It's K, L, M. N is equal to 3. Maximum number of electrons will be given by 2n square. That is 2 into 3 square. What is 3 square? 9, right? So 2 into 9, that is 18. Yes, Lakshmi, now it's time for the leaderboard. As I promised, I'm going to announce the score right after this question. So let's see. And let's load the leaderboard. And let's use leading the leaderboard. Okay. Within a minute, we'll get to know. And it is reconnecting I Love Byju's is at the top. Great. Then we've also got Vidushmita, Shakti is here, Priyanshu, Ritvik, Arunab, Samriddhi, Ayushi. So many of you are here. Great. Nice. 1/3 incorrect, Ayushi Singh. That's not a problem. Ritvik is 4th. 5th. 5th, Ritvik. Nice. Awesome. Great, guys. I must say, this is your best performance so far. I'm really happy to see that you people are clicking on the right answers. Chalo. All right. Aage badhe? Are you ready for the second part? Yes, give me a quick thumbs up. Shall we start now? All right, I can see loads of thumbs up. So let's begin. Be very careful because you can still change how this leaderboard is looking. Question number 4. And let's load the question for you people now. Let's see what the question says. The question says, maximum number of electrons that can be accommodated in the valence shell, and this valence shell that we're talking about can be L, M, N and so on, of an atom is 2, 4, 8 or 10. Now please note over here that we're talking about valence shell, and the shell in consideration can be L, M, N and so on. You need to really read the question very, very carefully, and then only you can easily understand what needs to be done. Again, most of you got this one right. 64 of you got this one right. Well done. Awesome. Great, guys. Yes. Correct, correct, correct. That's how the chat box is looking right now. All of you have marked option C. When you people give the right answer, it makes me really happy. Alright, so the maximum number of electrons that can be accommodated in the outermost orbit is 8, except if it's the K shell. For K shell, it's going to be 2. Yes, I am also happy to see those happy emoticons. Smiley emojis. Awesome. Great. Chalo, let's move on. Let's see what is question number 5. Leaderboard, I'm going to show you. Don't worry. First, you need to solve question number 5. And let's load this question for you people. Be very careful with this one, okay? Which of the following is not a possible electronic configuration? 27, 281, 272, 21. Recall all the rules, how we are distributing electrons in various shells, right? I hope you're not having a tough time evaluating this answer. Let's see. Read the question carefully. It says not a possible electronic configuration. Not a possible. Okay? And your time's up. Let's see. How many of you got this one right? Most of you got this one right. Great. Yes, I'm sure the rest of you might have skipped this word not. That's why it's very important to read the question very, very carefully. Sometimes we know the answer. We know what needs to be done. But in a hurry, we kind of just overread stuff, right? It's okay, you make all the mistakes over here. That is not a problem. But then learn from your mistakes. That is more important. Electronic configuration 272. This is wrong. The reason being, in this KL, the next shell, L shell is not completely filled, right? it can still accommodate one more electron. So what is going to be the right electronic configuration for this? Let's see. Write the right configuration in the chat box over here. Then we'll move on to the next question. It's given 272, which is incorrect. You need to tell me the right one. Here, the inner shell is not completely filled. That's why we are taking it to be wrong. Pratiksha, Narendra, Disha, Dhera, you all are absolutely right. Hey Sriram, just check your answer again. Akshay, correct, 281. 281 was the right configuration. Yeah, so if you get a question like this, now you can easily correct it also. Yes, Maulik. Well done, Shilpi. Himanshu, you're also right. Lakshmi, Ashok, J.A., Papya, all of you are absolutely right. You people have understood all the concepts thoroughly. Now it's time to solve question number 6. Let's see. Let's load this question and let's try solving this quickly now. If the K and L shells of an atom are full and the M shell has 5 electrons in it, identify the total number of electrons in the atom. Come on guys. All you need to do is just add them correctly, I would say. Basic mathematical question. Of course, you need to apply chemistry, right? You need to know how many electrons you can put in K and L shells. And then they've given you that M shell has 5 electrons. And your time's up, guys. Let's see. Let's see how many of you got this one right. Hey, most of you got this one right too. I'm telling you, this is actually by far your best performance. Really happy. You people are making me really happy. Yes, Masoom question. Yes, Mukesh. 2 plus 8 plus 5. So, K shell can accommodate 2 electrons. Why? Because N is equal to 1. L shell can accommodate 8 electrons. Why? Because N is equal to 2 over here. So, 2 into 2 square, 8. And they've given you in the question that M shell has 5 electrons. So, all you need to do is now add the electrons from every shell. So, it's going to be 2 plus 8 plus 5. That is 15. Yes, Disha. Awesome. Great. Chalo. Now, this is the final question. That means you need to be really quick with this one. You have to get this one right. Because after this, I'm going to show you the leaderboard, right? Anything can happen now after this question. Are you guys ready for this one? Shall we start now? Alright, Gungun is giving thumbs up. चलो गुनगुन की बात मानते हैं, स्टार्ट करते हैं. All the best, guys. Try getting this one right. Let's see what the question is. Which of the following is neutral in nature? Is it electron? Is it proton? Or is it neutron? You have to tell which is neutral in nature. No charge. Is it an electron? Is it a proton? Or is it a neutron? These are the 3 options being given to you. And now, well, I guess you people are going to guess this one right. That is my estimation, and I hope it comes out to be true. Now, my question is, how quickly can you answer this one? Sahi karoge, that I'm taking for granted. All right, almost everybody got this one right. Great. 72 of you got this one right. Option C, that is neutron, was the correct answer. So, we all know electron has a negative charge, right? Proton has a positive charge. An easy way to remember, I told you in the class also, P proton, P positive. You'll never forget this then. Neutrons, they are neutral. The name is self-explanatory that neutrons are neutral. It has no charge. Awesome, guys. Well done. Let's see. Let's load the leaderboard and let's see if I Love Byju's is still at the top or has it changed. Great. Reconnecting. I Love Byju's is still at the top, but we've got Aruna, Vashima, Vidushmita, Shlok, Arushi, Kashish, Ayushi, Ritvik, Samriddhi. All of you there up in the over here. Awesome. Great, guys. Well done. Well done. If you're here, if your name is here, it's great. I'm really proud of you. If your name is not here, not a problem. You must have done some silly mistake. You can always go back, watch the video again. You would understand where you made a mistake, and you can always learn from your mistake, right? Our purpose is not to make mistakes in the exam. When you have your final exams, right? There you should not be making mistakes. Here you're allowed to make as many mistakes as you can. Silly mistake, yeah, I know. You must have made a silly mistake only. Yes, absolutely. Jaldi mein galat kar diya. Not a problem. It happens, Sometimes we just want to answer it quickly. हमें लगता है हम सबसे पहले answer कर दें. And at times, because of that, we click on the wrong option. So guys, we've got you covered and we've got amazing sessions for you people. All you need to do is tune in and watch those sessions from Monday to Friday, because these sessions are definitely going to make you exam ready. Now, our upcoming session is going to be on this topic, atomic terms. And it's going to be an amazing session. So, A for atomic, A for amazing. And I want all of you to be there on 9th February, that's a Wednesday, 1 week from now at 5 p.m. So, I hope you all will be there and you will revise whatever we've covered till now so that that class goes really well. There's also a free trial class link being given to you in the description box. So if you want, you can go ahead and take this free trial class. I'm sure you're going to love that class. Yes, A for awesome. Nice. Alright. Well, quickly like this video, like all the videos, right? Because we love studying together, isn't it? Share this video with your friends and we can have more people over here then. So Menti Quiz will be more interesting that way. And of course, don't forget to subscribe to our channel. Thank you. Thank you so much. Thank you, Ankita. Thank you, Harendra. Hey, Ruhi. Thank you. Alright, chalo. It's time to sign off now, but I'll see you in the next session. Until then, you people, please keep practicing, stay safe and take care.